Okay, so today we are going to be using indirect measurement to solve real-world problems. And this is going to be a super quick section. You only have about 12 problems in your skills practice book to do. So in this particular section, you're going to be, again, using similar triangles to calculate indirect measurements. And we're going to be using proportions in order to determine our unknown lengths. So if you look in your student textbook, problem number 2, about page 498, you go to the park and you use the mirror method to gather enough information to calculate the height of one of the trees. The figure here shows your measurements. Calculate the height of the tree. Okay, well, the mirror measurement, or the mirror technique, simply states this, that your angle of incidence equals your angle of reflection. So this is your angle of incidence. Incidence equals your angle of reflection. And this makes sense because if we have a straight line and you have like this, we've got an angle of incidence, so this is the angle that you're going to see something, and then the reflection part is going to be the same measure. So this angle here is going to equal this angle here. Okay, it's not very easy to see when I'm dealing with lines that are not straight because I can't draw straight lines, but without a measuring device, but that's what we need to learn. So the angle of incidence equals the angle of reflection. Okay, so here, if you are standing and you are 5 feet tall and you look down and there's a mirror right here, this angle here is going to be congruent to this angle over here. Okay, so now we have these two triangles and they are going to be similar by the angle-angle similarity theorem. We've got a 90-degree angle right here and here. And then we've got that this angle here, the angle of incidence, equals the angle of reflection. So these two angles are also going to be congruent. So by angle-angle similarity theorem, we know that these two triangles are congruent to, or are similar to each other. So when we look at this, we've got that this is 5.5 feet, and this here is 4 feet. And then if we look at this other triangle and we draw it so that corresponding parts are in the same location, we have the 90-degree angle here, and we know that if this total distance is 16 feet and this area or this distance here is 4 feet, we know this is 12 feet. So we've got this is 12 feet. And what we're looking for is the height of the tree. So we're looking for this piece right here. So if we set up our proportion so that we have the corresponding pieces in the same locations, we would say that we've got 5.5 feet over 4 feet is equal to x feet over 12 feet. Okay, and now if we cross multiply, we've got 12 times 5.5 is equal to 4x, and we would divide both sides by 4 and get our answer. I do not have a calculator right here next to me, so I'm not going to do that. But our answer would be in feet, and that would tell us what this distance over here is. Okay, so Stacy wants to try the mirror method to measure the height of one of her trees. She calculates that the distance between her and the mirror is 3 feet. So we're going to have to draw this. Okay, so we're going to draw this here. Okay, so this over here is our tree. The trunk's got to go farther. Okay, and then this over here is our person. Okay, so she calculates that the distance between her and the mirror is 3 feet, so the distance here is 3 feet, and the distance between the mirror and the tree is 18 feet, so this distance over here is 18 feet. Stacy's eye height is 60 inches, so the distance from her eyes down to here is 60 inches. So that's inches. Draw a diagram of the situation and then calculate the height of the tree. Okay, well, the first thing we need to know is that 60 inches is the same as 5 feet, because we know that 1 foot is 12 inches, and our inches would cancel here, so we have 60 divided by 12 is 5 feet. So you want to have all your units in the same, you want to have all your measurements in the same units. So now we've got 5 feet here. We know that this is a 90-degree angle, and we know this is a 90-degree angle. So if we set up our two triangles, we have that this is 5 feet, and this is 3 feet, and then we have that this would be 18 feet, and this is our unknown. So if we set up our proportion, you want to have the same pieces in the same locations. So we're going to have our 3 feet and 18 feet in the denominators, and our numerators we're going to have 5 feet over x feet. And now if we cross multiply, we would say 5 times 18 is equal to 3 times x, and then we would divide both sides by 3. And when we do that, we get that the tree is 30 feet tall. Okay. So this is another one. Stacy notices that another tree casts a shadow and suggests that you could also use shadows to calculate the height of the tree. She lines herself up with a tree shadow so that the tip of her shadow and the tip of the tree shadow meet. And then she asks you to measure the distance from the tip of the shadow to her, and the measure from the distance from her to the tree. Finally, you draw a diagram of the situation as shown below, and you calculate the height of the tree. So this, again, is just using similar triangles. And our similar triangles here are, we've got this triangle here, this triangle here, okay, so if we draw this, we've got that this is 5 feet, or 5.5 feet, and this is 6 feet. And then we have this larger triangle right here. Okay, and again, these are similar by angle-angle similarity theorem, because we've got, here's our larger triangle, and we know that this distance here, 15 and 6, is 21 feet, and this is our unknown. Okay, but we know these are similar by angle-angle similarity because they both have 90-degree angles, and then they both share this angle right here. Okay, so by angle-angle similarity theorem, we know these two triangles are similar, and then based on that, we can set up a proportion. And what we know is that we want to put these in corresponding locations. So we can say x over 21 is equal to 5.5 over 6. And then if we cross multiply, we would say that we've got 21 times 5.5 is equal to 6x, and then divide both sides by 6. And again, I don't have a calculator right at my fingertips, so I'm going to let you figure out what the actual height is. But what we do know is that the height would be in feet, and so whatever our value is for x, it would be in feet, because every other value here is in feet. Okay, so the last type of problem is going to be something that's like, how wide is that creek? You stand on one side of the creek, and your friend stands directly on the other side of the creek from you, as shown in the figure below. Your friend is standing 5 feet from the creek, and you are standing 5 feet from the creek. Okay, you and your friend walk away from each other in opposite parallel directions. Your friend walks 50 feet, and you walk 12 feet. So if we look at this now, we can see that we've got these parallel lines. Okay, so we have this line here, and that's parallel to this line here. Okay, and then again, we've got that we are directly across from our friend. So we've got this here, which when we're directly across and then we have parallel lines, we have, we've got 90-degree angles here. So we have 90-degree angles, and then we've got these parallel lines. So if we want to know a distance, we can see that this would be considered a transversal. Okay, so this distance here is considered a transversal. Okay, so then when we look at this angle here that's formed and this angle here that's formed, we know that they're congruent because they are alternate interior angles. Okay, from our parallel lines, we've got this transversal, and the angles formed would be alternate interior angles. And what we know, alternate interior angles are congruent. Okay, so because they're congruent, and because we have this 90-degree angle here, we know that these two triangles are similar. Okay, so our triangles that are formed are like this. We've got this 90-degree here and this 90-degree here. We know that this is, if we look at the small triangle first, we've got that this is 5 feet and this is 12 feet. Okay, but and that's the total distance here, but on this side, we've got to take into account the whole river, right? So we don't know, we know that this little piece is 5 feet, but we don't know this entire distance. But what we do know is this distance here is 50. Okay, so that's going to correspond here at 50. Okay, so we know these are similar triangles because this angle here and this angle here are congruent based on alternate interior angles. And then we have this 90-degree angle right here. So can we determine, I'm sure I'm getting ahead of myself, but can we determine what the distance is of the creek? Okay, so we can measure the width of the creek by using similar triangles. And if we set up our proportion here, this is our unknown, we would say it's x divided by 50 is equal to 5 divided by 12. And when we cross multiply, we get 12x is equal to 50 times 5, which is 250. So we have 12x equals 250, and we would divide both sides by 12, and we get x is equal to, I don't know off the top of my head, and so we have this total distance, but the total distance is the distance from, let's pick another color, from here all the way to here. But that's not the width of the creek. The width of the creek would be 5 feet less than that. So we would have to take what our final angle measurement is, or our final distance here, and then we would subtract 5 feet from it in order to determine the distance from one side of the creek to the other. So you're going to take this number that you get here and you're going to subtract 5 to get the distance from one side of creek to the other. So similar triangles are super helpful because they enable you to really determine distances without knowing all the pieces. Okay, so you only have a couple questions, well, about 12 questions to do in your skills practice book. So give them a shot. That's what we'll be doing in class on Wednesday. So have this video watched before then, and then we will get busy working on Wednesday. Thank you.